Hi everyone, my name is Gabriela Tavares and I am currently a PhD student at the Faculty of Medicine in University of Coimbra, Portugal. And I'm going to present you now my poster, which is entitled Modulation of dopaminergic signaling with bromocriptine improves glucose and lipid metabolism in an obese type 2 diabetic animal model. So, the well-known action as neurotransmitter for dopamine is well recognized, but lately in recent years, dopamine has also been attributed as a neurohormone, mostly because it is produced outside the brain at the adrenal gland, at the carotid bodies, as well as in the gastrointestinal tract. Also, the dopaminergic signaling, the D1 and D2 receptors are present in several peripheral tissues, such as the white adipose tissue, as well as the liver and in the kidney. And actually, dopamine have an anti-incretin role inside the beta cell pancreatic in the pancreas, of course. Therefore, targeting the dopaminergic signaling may constitute a target to treat these metabolical disorders such as obesity as well as type 2 diabetes. In fact, this new formulation, that is bromocriptine, which is a dopaminergic receptor 2 agonist, have been approved by the FDA to the treatment of type 2 diabetes, mostly because it showed an improvement in insulin sensitivity as well as glucose control. But we are lacking studies regarding what happens in the insulin sensitivity tissues, in the peripheral tissues as well. Therefore, we came with this experimental design in which we aim to evaluate whether bromocriptine can improve insulin sensitivity and glucose and lipid metabolism in the white, the brown adipose tissue, and also in the liver. And to do that, we use as a healthy control Wistar rats fed a standard diet, and we use a diabetic model, which are the Goto Kakizaki rats, that I'm going to further on call them GK rats. We kept one of the group fed a standard diet, so they remaining only diabetic, and the other three groups we fed a high caloric diet in order to mimic our Western society, where mostly what happens is that obesity leads to insulin resistance, and then ultimately it turns to a type 2 diabetes phenotype as well. Therefore, to mimic this in our society, we fed these animals with a high caloric diet, enriched with fat and also with sucrose. And then we choose one group to treat with bromocriptine during 1 month at the dosage of 10 milligrams per kilogram by IP injections. Then we sacrifice our animals in 2 separate time points, at the fasting period and also at the postprandial period. And we do that because we know that plasma levels of dopamine also are modulated by the intake of nutrients. So we would like to see what happens regarding the dopaminergic signaling as well as in the metabolic players. If we consider our results regarding the systemic analysis of these animals, we can surely see by this graph that the animals fed a high caloric diet gain weight throughout the time, comparing to this gray line that are only the diabetic model that we presented better in this A2 figure. And as you can see by this red line, actually the animals that are treated with bromocriptine do not gain weight during the treatment time. And it is also represented here in this graph. And as well as it also decreased their caloric intake. Accompanying these results, we also saw an improvement regarding lipidic metabolism, since plasma levels of triglycerides, cholesterol, as well as fatty acids decreased after the treatment. And we also could see an improvement regarding glucose metabolism, since we have a decrease in the fasting glycemia levels after 6 hours fasting, as well as a decreased area under the curve during the insulin tolerance test. Without changing the hormonal levels of insulin between the GK animals, neither the glucagon plasma levels between all the groups. If you take now attention to our results regarding the epididymal white adipose tissue, we can see that their mass also reduced in the treated animals, that are accompanied by a decrease in leptin release. And interestingly, the adiponectin levels remain constantly between groups. Moreover, and very fascinating, is the fact that we have a huge increase of GLUT4 levels. As well as we have here a trend to the increased levels of insulin receptor phosphorylation, mainly during the fasting period, that are not sustaining postprandially. The PPAR gamma levels are also increased with the treatment, as well as the phosphorylation of AMPK, suggesting that there are more oxidation of the fat in this tissue, and this can be mostly regulated by the fact that we also have able to show an increase in the dopamine receptor 1 protein levels, mostly in fasting, that are not postprandially sustained. And regarding the D2 receptor levels, we do not see any changes between the groups. Moreover, if you look in attention now to the brown adipose tissue, you can see similar results, because the glucose transporter 4 are also increased in this tissue, as well as the phosphorylation of the insulin receptor. And in this tissue specifically, there is no alterations between regarding the dopaminergic receptors D1 or D2. Interestingly, if we saw now these histological images of the liver tissue, what we can see here is that the three high caloric fat animals are in the right panel, and as you can see, the control one, that is the upper one, and the one that is injected with a vehicle solution, can show this vacuole-like shape that are fulfilled with lipid droplets mostly, and are consistent with a phenotype called liver steatosis. And if you look to the middle panel, that are the one that are animals treated with bromocriptine, we completely revert this phenotype to a control aspect, that is accompanied by the fact that the liver weight are also reduced in these animals, mostly because they lose their fat on the liver, and also they present less amount of hepatic triglycerides. And moving now to these graphs, we also can see that actually the D1 receptor is the one that is with higher expression levels. Therefore, and taking this all into account, our hypothesis is that by using an agonist for a D2 receptor, maybe the cells in the white adipose tissue are expressing more D1 receptors in order to increase the AMP cycle levels to activate the catabolic pathways in order to put all the fat to oxidation. And by doing that, as we can see, we mobilize the fat from the liver to the white adipose tissue where they are more oxidized by this graph here. And by doing this, we believe that bromocriptine is reducing lipotoxicity as well, and in this way we are improving the glucose metabolism as well as insulin sensitivity in the peripheral tissues. So this is it. Thank you for your attention.